Real number system basically branches off two separate directions here. You have irrational numbers and you have rational numbers. Kind of like you have rational teachers and irrational students. Just kidding. Irrational numbers would be things like pi, square root 2, square root 11. Basically, those numbers, if you think about it, as a decimal, they would go on forever, never repeat, never terminate. These are not perfect squares. A rational number are anything that can be written as a fraction. So things like 1/2. 1/2, if you think about it as a decimal, it would terminate, 0.5. 1 and 1/3 is a rational number. Again, it's a fraction. As a decimal, that would repeat. So note the difference. Repeat, terminate, versus goes on forever, continues, never repeats, never terminates. Rational numbers also have a few other subsets that they belong to, and that would be integers. Integers are rational numbers. Integers, again, are positive, negative whole numbers including 0. So you'd have such as -3. Well, you can make that a fraction by putting it over 1. Whole numbers are a type of integer, again, a type of rational number, so it just kind of climbs the ladder. It belongs to all of them. Whole numbers are basically non-negative counting numbers, including 0. So you have 0, 1, 2, 3, 4, 5, 6. Natural numbers are basically positive numbers, positive counting numbers minus 0. So 1, 2, 3, 4, 5, 6, 7. First type of question, which numbers shown belong to which of the following subsets of real numbers? We look at the first group here. All of those are fractions. Well, if they're all fractions, we know that they're rational numbers. So if it's a rational number, it's not irrational. Other things that fractions are not. Okay, fractions are not integers, fractions are not whole numbers, fractions are not natural numbers. We have also the square root of 4, which is 2, and the square root of 16, which is 4. So all this group contains would be rational numbers. It does have integers, but not all of them are integers because of this group of fractions here. So the only thing that this would be considered as rational numbers, this group. Checking out the second group, you have 0. And all of these positive whole numbers. So these are whole numbers. Whole numbers include zeros. Well, if they're whole numbers, they have to be rational numbers. Therefore, they are not irrational. These are also integers. Integers are positive, negative, whole numbers, including 0. The only thing that they're not would be natural numbers. Why are they not natural numbers? Because it includes 0. So these would be whole, integer, and rational. Other things you may have to do is compare some of these rational and irrational numbers with an inequality. Basically, if you check it out here, you have 48, the square root of 36, or 38. Basically, what you're going to want to do is use your perfect squares to get you in the ballpark, which I just mentioned, which was the square root of 36. Square root of 36 is 6. 38 would be after, the square root of 38 would be after that. And then you would have the square root of 49. Those are two perfect squares. So basically, 38 is between 36 and 49, which means your answer would be between 6 and 7. 38 would be closer to 36, so you could say that this is approximately, I don't know, 6.2, 6.1. So then you can go ahead and compare this. 48 would be greater than 6.2. So A would be our option. Comparing from greatest to least, the best way to do this is to go ahead and get all these answers as a decimal. They give us one decimal right here, 6.57. This is pi, we know is approximately 3.14. We have 11 halves. Well, 2 goes into 11 5 times, which has a remainder of 1, so 1/2, which would be 0.5. That would be 5.5. Square root 65, again using two perfect squares. You have the square root of 64, which is 8, and the square root of 81, which is 9. 65 would be between square root 64 and square root 81, and it's very close to the square root of 64, so we're going to say that this is about 8.1. So comparing your decimals, 8.1, 5.5, 6.57, and 3.4, 8.1 is the largest, which is the root of 65. Next, we have 6.57. So this guy's gone. Then we would have 11 halves, and last but not least, pi, which would be option C. Operations with rational and irrational numbers, what you need to remember here is anytime you take a rational and a rational, whether you're adding or multiplying, you will always have a rational outcome. So rational to rational is rational. Anytime you have a rational to an irrational, so they're different, when they are different and you add or multiply, it is always irrational. Rational to rational is rational. Rational to irrational is irrational. The only trick here is sometimes when you take an irrational and an irrational, you can potentially get a rational or an irrational outcome. But 9 times out of 10, when you take a irrational and a rational, you will get an irrational outcome. It's just on occasion. An example would be this. You have an irrational number, say square root 2 times the square root of 2. Both of these are irrational, but when you take this, you get the square root of 4, 2 times 2. The square root of 4 is 2. So that would be an example where you'd have a rational outcome. Again, majority of the time, when you take an irrational and an irrational, you would get an irrational outcome. Here's an example where you're multiplying two real numbers together, and this would be a rational times an irrational. Again, square root of 82 is not a perfect square, so therefore it's irrational. Remember, when they are different, rational and irrational. Checking out that last slide, rational and irrational, you will always have an irrational outcome, which would be option A, irrational outcome. This concludes real numbers containing rational and irrational numbers.